In this presentation, we're going to review the major engineering disciplines. These include those that are listed here. The number of engineering disciplines goes far beyond what we've listed here and is not actually static. New ones can be developed over time. And many of those listed here have additional sub-disciplines within them. These are just the 12 that we'll be discussing today. So let's look first at biological engineering. This is a highly disciplinary field. It integrates physics, chemistry, math, and computer science with engineering principles to study biology, medicine, behavior, and health. There are three major areas to biological engineering, and these are based on the size of the molecules. So one of those is biomaterials. Biomaterials engineering involves molecules that are in the micrometer size. And this includes cellular engineering, tissue engineering, and various implants. Biomolecular engineering is the study of nanometer-sized molecules, so even smaller than the ones I mentioned previously. And applications of this include drugs, genomes, and protein engineering. And finally, we have biodevice engineering under this discipline. And these are the larger size molecules, millimeters to meter size, and involve all sorts of implantable biodevices, medical instrumentation, and robotics. Bioengineering is really exciting because it has direct applications to saving lives through gene therapy, vaccines, medicines like insulin. There are a lot of bioengineering careers that are available to go into that fall under the three major subdisciplines that I just mentioned. You can read the list here, and actually what's also interesting is that the Bureau of Labor Statistics has a lot of information about all of the engineering careers I'll be going over today. So I wanted to take a moment to give you an example of that and what that looks like. So this is the Bureau of Labor Statistics website. Notice at the top, www.bls.gov. And this particular site contains the employment statistics for the United States as of May 2019 for bioengineers and biomedical engineers. And this is a very useful website for information about all types of engineers. So there's all of the types we're going through. You can find a link here. And what's available to you is the industries that bioengineers work in, about how many people work across the country by state in terms of employment numbers, and then where they're located, the mean wage, more of employment by bioengineers by area, and more of the same. I think there isn't. So anyways, this website is very useful in getting a lot of information that you may be interested in about the types of industries that any engineer works on, what their average wage is, and where the jobs are according to the maps. So I highly encourage you to visit this site for any field that you are interested in learning more about. And here on this slide we have a few examples of the type of devices that bioengineers work on. All right, civil engineering. This is actually one of the oldest branches of engineering and also one of the largest out of all of the ones that we're talking about. It encompasses a broad range of fields, including bridges, highways, airports, tunnels, water treatment, to protecting the environment. So it's really about designing the world around us. And all of the infrastructure that goes into our cities is actually something that civil engineers touch. Challenges that civil engineers will address in the future include innovative solutions for adapting these systems to climate change and increased urbanization, As a civil engineer, you'll be faced with creating innovative ways to build and improve infrastructure given these challenges. So let's look at the major disciplines of civil engineering. We have 6 listed here, and I'll go through each of these individually. Structural engineering is where we look at designing bridges and buildings to where they can withstand high loads that include earthquakes, hurricanes, and major snowstorms. It includes anything from the world's tallest building, which you see here on the right in Dubai, to something more affordable and sustainable like a bamboo school, which is shown here. Environmental and water resources covers everything from getting clean drinking water to dealing with wastewater so that we don't pollute our streams and oceans, but also so that people don't get sick from wastewater getting back into the drinking water sources. It also includes air quality, land protection and cleanup, and it can be large citywide water projects all the way down to personal aquaponic projects for women in Ghana. So it really encompasses a wide range of projects. Geotechnical engineering is the base of everything, if you could imagine. If you don't have a good foundation and good soil under you, your structure will fail. So whether it's an earth dam or a tunnel, you need to understand the geology and the geotechnical engineering of the structure. Transportation engineering encompasses everything about getting you and the services and goods you want anywhere you need to go. That includes airports, light rail, our ports, and even how to safely create pedestrians and bike lanes to exist with cars. And finally, construction engineering is a critical component to any project because it has to be built correctly. So construction engineers work on the business and management side of projects, where they may consider how do you make this happen, how do you build a multi-story high-rise building and have everything go smoothly, to how do you make sure that a structure is safe before it's 100% built. Finally, and next we'll look at architectural engineering. Architectural engineers actually work alongside architects and very closely often with civil engineers, and they're always looking at safety and cost and construction methods for our buildings. Next we'll look at mechanical engineering. If you find yourself interested in how things work, or if you like to design and build things, or if you have been fascinated with cars, robots, spacecraft, airplanes, then mechanical engineering might be a really good field for you. It combines physics and math very heavily. Basically, if it moves or uses energy, a mechanical engineer was probably involved in it, in designing it or understanding it. After civil engineering, it is the second oldest branch of the engineering disciplines. And here are a few images of devices that mechanical engineers have worked on. If you take a moment to look, you'll see that most of these have some type of motion or a structure that holds something up or has some sort of energy conversion and power. All of that involves mechanical engineers. So mechanical engineers are involved in designing things and controlling systems, dealing with inputs and outputs, and understanding how systems behave. So anyways, that's mechanical engineering. Where do mechanical engineers work? Well, they work in all sorts of industries as listed here: architectural engineering, machinery, manufacturing, transportation, computers, research, and development. And locally, we have several companies that hire mechanical engineers, including all of those you see here. You can see that it spans from electrical manufacturing and semiconductors to the biotech industry. There's a broad range of applications for mechanical engineers. Now let's look at aerospace engineering. Aerospace engineers design, develop, test, and produce technology for commercial aviation, the national defense, and space exploration. There are 2 subcategories of aerospace engineers. Those who work with aircraft are called aeronautical engineers, and those who work with spacecraft are considered astronautical engineers. Aeronautical engineering focuses on the theory, technology, and practice of flight within the Earth's atmosphere, whereas astronautical engineering focuses on the science and technology of spacecraft and launch vehicles. So a little subtlety there. These are the employers of aerospace engineers: Boeing, NASA, Lockheed Martin, and many space systems. According to the Bureau of Labor Management, aerospace engineers work in the federal government, in engineering services, in research and development, in manufacturing. So you can also find them across a wide area of industry. Next, we have industrial engineering. Industrial engineers organize people, information, energy, materials, and machines involved in the production process. Basically, they are finding ways to eliminate wastefulness in production processes. They really focus on devising efficient systems that integrate workers, machines, materials, information, and energy to make a product or provide a service. And as you can see, there's quite a lot of things that industrial engineers might be involved in, and you can take a moment to read over this list. But as you do, just look at the top here. You have the word hospital, you have simulation modeling, you have manufacturing, you have automobiles, ship and dockyards. So industrial engineers work across a wide area of industries within the U.S. There are a few specialties in industrial engineering. We have management engineers who combine the knowledge of business and facilities. We have ergonomists, operations analysts, and quality engineers. As I mentioned, industrial engineers work across a variety of industries, including transportation, computer science, machinery manufacturing, the food sector, the tech industry, medical sciences, pharmaceuticals, and even at the moment, Ghirardelli Chocolate Company is looking for an industrial engineer right now. Manufacturing engineers are actually industrial engineers that focus entirely on the automated design and operation aspects of manufacturing processes. And again, they're looking at optimizing computer networks, robots, machine tools, and materials handling equipment for these processes. So we'll pause here and continue on the next 6 disciplines of engineering in the next recording.